There is no camera on it. There is no seismometer within 17 miles. There is no real-time monitoring network of any kind positioned on its flanks or near its summit. The closest functioning sensor belongs to a different volcano entirely, Mount Kupreanof, 27 kilometers to the east, and it was not designed to watch what is happening beneath Mount Kupreanof right now. What is happening, according to the Alaska Volcano Observatory's official information statement issued on June 22, 2026, is this. Magma has intruded to relatively shallow depths beneath the volcano. The ground above it has risen by 10 centimeters in 8 months. Sulfur dioxide is venting at rates between 100 and 800 tons per day. Emissions consistent, in the observatory's own words, with degassing from relatively shallow new magma. More than 30 earthquakes of magnitude 1.0 or greater have been detected since May 12th, including a magnitude 3.6 on June 16th. And the volcano producing all of these signals has no known historical eruptions. Not one. In the entire written and geological record, Mount Kupreanof has never been documented erupting. Scientists do not know what it will do when it does. Mount Kupreanof sits on the Alaska Peninsula, one of the most volcanically active stretches of land on the planet, an extension of the Aleutian Arc, the 2,900-kilometer chain of volcanoes where the Pacific Plate subducts beneath North America at roughly 7 centimeters per year. That subduction drives water deep into the mantle, generating the magma that feeds hundreds of Alaskan volcanoes. Most of them are actively monitored. Most have historical eruption records and seismometers on their flanks. Mount Kupreanof has none of these things. It is a stratovolcano, the same steep-sided, layered volcanic structure as Mount St. Helens, Mount Pinatubo, and Mount Vesuvius, rising to 6,217 feet above the Alaska Peninsula. It is heavily glaciated, meaning its flanks are covered in ice that has accumulated over thousands of years of Arctic temperatures. That glacier is not a cosmetic feature. It is a significant volcanic hazard in its own right. When magma encounters glacier ice, the interaction is violent and fast. Meltwater generated by the heat of an eruption has nowhere to go except outward, down the flanks of the volcano, mixing with volcanic debris, accelerating into the valleys below as a lahar. A lahar is not a lava flow. It does not move at the walking pace that popular imagery suggests. A large lahar moves at highway speeds, 40, 60, sometimes 80 kilometers per hour, carrying a slurry of water, rock, ash, and ice debris that buries everything in its path under meters of solidified volcanic concrete. The Alaska Volcano Observatory's June 22nd statement noted that eruptions at Kupreanof will likely produce lahars and pyroclastic flows on the volcano's flanks and into the surrounding uninhabited valleys. Uninhabited, for now. The Alaska Peninsula is not densely settled, but it is not empty either. King Salmon, population approximately 400, sits roughly 70 kilometers to the northeast. Cold Bay, with its strategically critical airport, one of Alaska's most important fuel and emergency diversion points for trans-Pacific flights, is approximately 100 kilometers to the southwest. And above Kupreanof, crossing the Alaska Peninsula at regular intervals throughout every day, are the trans-Pacific flight corridors connecting North America to Asia. Dozens of commercial flights pass within potential ash cloud range of this volcano every single day. Volcanic ash is not the ash from a campfire. It is pulverized rock, angular, abrasive, and electrically charged. It destroys jet engines. When ash particles enter a turbine, they melt under extreme heat, re-solidify on cooler surfaces, and cause catastrophic failure within minutes. In 1982, a British Airways 747 lost all 4 engines flying through an ash cloud from Indonesia's Galunggung volcano. Pilots were unable to restart them for 13 minutes before finally succeeding at low altitude. Every volcano on the Aleutian Arc represents a potential hazard to trans-Pacific aviation. Most of them are monitored. Mount Kupreanof, as of this video, is not. Here is what scientists are working from. Since February 2026, shallow seismicity beneath Mount Kupreanof began to increase. The earthquakes were small, magnitudes mostly below 2.0, but their location, directly beneath the volcano at shallow depths, and their character, consistent with fluid movement rather than tectonic stress, prompted the Alaska Volcano Observatory to raise the volcano's alert level to yellow on May 12th. That is the second level on a 4-level scale. It means elevated unrest, above background levels, not yet indicating an eruption is imminent, but demanding close attention. Then, in mid-June, the snow melted enough that satellite radar could finally see the ground surface. What INSAR, Interferometric Synthetic Aperture Radar, the same satellite technology that detected ground deformation before the Venezuela earthquakes, revealed stopped the team cold. The ground around Mount Kupreanof had risen by up to 10 centimeters over the preceding 8 months. The source of that inflation signal was estimated at approximately 6 kilometers below sea level. That is not deep. For context, the magma chamber beneath Yellowstone sits at depths of 8 to 15 kilometers. The magma that drove the 1980 eruption of Mount St. Helens was moving at depths of 2 to 8 kilometers in the weeks before the eruption. At 6 kilometers, Kupreanof's intruding magma is not at the surface, but it is not far. The sulfur dioxide data completes the picture. SO2 is the gas that tells volcanologists whether the unrest beneath a volcano is hydrothermal, driven by hot groundwater, or magmatic, driven by actual molten rock rising from depth. Water-driven systems produce little SO2. Magma produces it in quantity because sulfur is dissolved in magma under pressure and exsolves, releases as gas, as the magma rises and pressure drops. Kupreanof has been producing between 100 and 800 tons of SO2 per day since at least April. The AVO's own statement says those rates are consistent with degassing from new, relatively shallow magma. Not residual magma from an old system, new magma. Magma that was not there before February. Stop for a moment. 3 independent data streams: seismicity, ground deformation, and gas emissions, all pointing at the same conclusion. Fresh magma is moving beneath a volcano that has never erupted in recorded history, on a flank covered in glacial ice, with no real-time monitoring network close enough to detect rapid escalation before it becomes an eruption. The AVO is careful to note that magmatic intrusions do not always produce eruptions. That is true. Magma can intrude, cool, solidify, and produce nothing more than a sequence of earthquakes and gas that eventually subsides. This happened at several Aleutian volcanoes in recent years without a resulting eruption. The Observatory statement explicitly notes that the earthquake activity, deformation, and gas emissions at Mount Kupreanof may cease with no eruption occurring. But here's the other half of that sentence, also in the AVO's own statement. If the magma rises closer to the surface, it will likely lead to increased unrest, change in the rate and style of seismicity, surface heating, and increased gas emissions that would allow advance warning. That phrase, advance warning, is doing a great deal of work in a situation where the closest seismometer is 17 miles away. Advance warning, in this context, may mean hours. It may mean days. For a glaciated stratovolcano with no historical eruption record, no established eruptive pattern, and no on-site instruments to measure escalation in real time, the margin of warning depends entirely on how quickly the satellite data can be processed and interpreted from orbit, and how rapidly the situation changes underground. Mount St. Helens gave scientists 57 days of escalating unrest before its catastrophic 1980 eruption, one of the most intensively monitored volcanic events in American history, with seismometers on its flanks and a dedicated team nearby. The eruption still killed 57 people, including volcanologist David Johnston, positioned 9.7 kilometers from the summit, with approximately 30 seconds between the onset of the lateral blast and the moment it reached him. Mount Kupreanof is not Mount St. Helens. Its eruption, if it occurs, will almost certainly be smaller. But the comparison is instructive. Even with 57 days of warning and intensive monitoring, an eruption can still move faster than the people closest to it. Kupreanof does not have 57 days of intensive monitoring. It has satellites, a seismometer 27 kilometers away, and the dedicated attention of the AVO team in Anchorage, who are doing everything the current infrastructure allows them to do, and who issued a clear and appropriately alarming information statement on June 22nd that almost nobody outside the volcanology community has read. That information statement ends with the AVO's plan for additional monitoring. If resources allow, the observatory intends to deploy additional seismic equipment and continue satellite observations. The words, "if resources allow," appear in a federal agency's official volcanic emergency statement about an active magmatic intrusion at an unmonitored volcano on one of the world's busiest trans-Pacific aviation corridors. The volcano is not waiting for resources to become available. It is moving on its own schedule, on its own terms, 17 miles from the nearest instrument capable of hearing it clearly. Subscribe to Seismic Alert. We will keep watching, because someone has to.